Good afternoon, everyone, and welcome to this week's episode of the M Word. My name's Robin. I'm the technical director here at Man Machine in the UK, and as always, it's an absolute pleasure to have you with me today. So, for today's session, we're going to be focusing on the AEC collection from Autodesk. That's the Architectural Engineering and Construction collection, and specifically discussing that with regards to AutoCAD users. So any of you out there that are using AutoCAD, whether it's AutoCAD LT, whether it's a vanilla AutoCAD or one of the many vertical flavors of AutoCAD that we have available from Autodesk, if you're using one of those systems, we're going to be talking about the AEC collection, talking about the tools that reside within that AEC collection, and we'll give you a couple of demonstrations along the way as well. For those of you that are new to this session, it airs every Thursday, or should I say most Thursdays, here on YouTube Live, and occasionally we broadcast over our Zoom private channel as well. And the idea really behind these sessions is just to share a tip, a trick, a workflow, or whatever else it might be on one of the Autodesk-based design tools or collaborative workflows. So over the weeks and months previous, we've talked about everything from Fusion 360 through to Revit, Inventor, Twinmotion, Enscape. We've covered so much, so don't forget to check out our YouTube channel, give us a like, give us a subscribe, and let us know what kind of content that you would like to see in future sessions. We're always looking for new and creative things to talk about. So yeah, you guys have some fantastic ideas, so keep those coming. So without any further ado, we're going to jump straight in. And as I say, the focus of today is the AEC collection, which from Autodesk is a fantastic set of tools for one single subscription where you get access to most design and collaborative tools that you may need to use inside of a construction workflow. So it has tools for 2D design, 3D design, whether it's conceptual or detailed design. We've got visualization tools, simulation tools, fabrication tools, all the way through to high-end photorealistic visualization, and even document and project management as well. So we clearly don't have time on this session to deep dive into every single one of those products. We'd be here for far too long, and my brain would be absolutely flabbergasted by the amount of detail that we'd have to go into to cover that on one of these sessions. But that said, I want to spend a moment just talking about them. So let's just shrink myself down into the corner. Helps if I press the right button. Let's shrink myself down into the corner, and then let's share my screen. So to start with, I've just opened up the Autodesk website because it's just worth sharing the sheer amount of products that we have inside of the collection. Within the collection, we have, let's say, some powerful design-based tools, first and foremost, that can be used to really drive and boost your productivity moving forward. Clearly, at the heart of that is Autodesk Revit, which we're going to be having a look at in product shortly. But we also have AutoCAD, including specialized toolsets. So if you want to stick inside of AutoCAD, but maybe you're mechanical biased, you get AutoCAD MEP. If you're using AutoCAD to do site design and maybe want to have a look at how vehicles can move around the site, whether it's a HGV or a car or something like that, we have vehicle tracking inside of the collection, which allows you to track vehicle movements around a site. All the way through to things like Civil 3D and InfraWorks, which are more infrastructure-based tools, where we can look at conceptually designing a site, some roadways and things like that using InfraWorks, all the way to detailed design of those inside of Civil 3D. So we have some core digital construction tools at the heart of this collection. These then move into like a collaborative environment. So let's take Navisworks, for example, the ability to be able to federate models together and clash them. So if you want to run a clash detection between structural elements and mechanical elements in your model, I'm going to sneeze in a second. If it comes out, I apologize. Excuse me. Apologies for that. Pollen seems to be quite high today. Now the summer's finally returned to the UK. So Navisworks allows us to clash detect models in a federated environment. and all the way through to online-based collaboration inside of Autodesk Docs. The amount of applications that you get in here is quite stunning. Again, we can't cover all of them today, but it's worth just taking that in and seeing for one single subscription the amount of tools that you get. Listed on this page is not Twinmotion, by the way. So Twinmotion is a tool that you get access to as part of a Revit subscription. So you've actually got the ability to use the Epic Games Twinmotion tool as well, which actually isn't listed on this page. Hello to the people on the chat. Thank you for joining us today. Apparently the sound seems a bit odd. I'm just going to hit a few buttons. Hopefully that sorts it out. Either that or someone's been in here that's far taller than me and maybe been playing around with my microphone. Hopefully that makes it a bit better. Let us know if that's made it any better on the chat. That would be useful. So we're going to focus firstly and predominantly inside of Revit. Again, the idea of this session is those of you that are using AutoCAD transitioning over to using the AEC collection and potentially something like Autodesk Revit. So inside of AutoCAD, you're using a 2D workflow. You're drawing your floor plans, you're drawing your site plans, and you're drawing your elevation in a very manual way. Nothing wrong with that, and absolutely there is always going to be a place and a part for AutoCAD inside of the design workflow. But there are tools out there nowadays, like Autodesk Revit from the AEC collection, that are designed to make you more productive. They're designed to allow you to work quicker, more collaboratively, more visually, and perhaps get more intelligent outputs from arguably the same amount of input. Apparently the sneeze fixed the audio, so thank you, Richard, for that. Good feedback. I'll try not to sneeze again in case it breaks it. So we're inside of Revit, and all we're going to do is just do a bit of a whistle-stop tour, really. So if you're brand new to Revit and you've just picked up an AEC collection, maybe the next sort of 40-45 minutes or so will be a nice introduction and a nice taster. We've got loads of these on our YouTube channel, so go and have a look at them. Some of them might go a little bit more in detail than what I'm going to go through today, but hopefully this will give you a good appreciation of exactly what's going on. I'm just going to turn my camera off for a second while I sort. So Revit's made up of two things, let's say. So inside of Revit, there we go. Inside of Revit, we have an RVT file. So an RVT file, you can call it the equivalent of your DWG. That's our model, okay? So that's our building, or certainly the element of the building that we are designing. So if we're architectural, this will be our bricks and mortar, so to speak. If we're mechanical, this will be our ductwork and our ventilation, so on and so forth. Now that particular Revit file is made up of a load of individual elements. We call those families. From an AutoCAD perspective, you will call them blocks. So a family, RFA, inside of Revit, is a component that's placed around the building. So think of our Revit project as your DWG, it's an RVT file, and think of our family as your block. Okay, they work, I guess, similar to a dynamic block in that they're intelligent and they can resize and they're parametric. Let's go ahead and create a new model. And from there, we can see that we're going to get a template pop up, just like you would inside of AutoCAD. And from that template pop up, these are all completely out of the box. I'm not running anything that is customized today at all. So it's all off the shelf. And from there, we're going to come on and just choose an architectural template. It doesn't really matter for the purpose of today which one we choose, but we're going to pick up an architectural template and click OK. Give that a couple of seconds to load. Once we've opened the main screen inside of Revit, again, you should feel very, very at home. I'm just looking at my t-shirt and it is the wrong t-shirt to wear against the green screen. So apologies for your eyes if they're flickering around. But I digress. So we're quite familiar once we get into Revit. The interface is similar to that of AutoCAD. Okay, we still have our application menu on the top left-hand side. where we access all of our application or file-based functionality. We still have the ability to open and save in our quick access toolbar on the top, as well as our help and subscription toolbar on the right-hand side. We still have a ribbon bar. The ribbon is still absolutely put into tabs and panels, and it's done naturally. So if you're looking for an architectural tool, like if I want to draw a wall, I will go to the architectural tab, I will go to the build panel, and I will find the wall tool. Likewise, if I wanted to draw some structural steel, I would go to either the structure or the steel tab, and I have some tools there to go ahead and use the beams or columns or trusses that I might want to place inside my environment. Now I'm using Autodesk Revit, full Revit, because that's what comes in the AEC collection. But again, if you're using Revit LT or something similar, then you might see some slightly different icons, or certainly less icons if you're using Revit LT. But again, we're talking about the collection, so we're talking about full Revit. Now let's just focus on what we have. So underneath our ribbon menu, we've got a properties palette, just like in AutoCAD. That can float onto a separate screen should you want it to. And we've also got our project browser. Now our project browser is the way in which we look through our file. So with Revit, we have a building, right? We have something 3D that we can spin around and look at and see. But predominantly, and this is what's important for you AutoCAD users, predominantly we're going to be editing that in 2D. Actually in Revit, we spend very little time manipulating and editing the geometry in 3D. We're mainly drawing using floor plans and elevations and sections, just like you would inside of AutoCAD. They're just more intelligent. So what we use our project browser for down here on the lower left-hand side is to segregate that model into different views. A view could be duplicated to show more or less information, and we'll get into that as we go through this demonstration. Now, on the right-hand side, just like AutoCAD, we have our real estate. And again, the controls are exactly the same. We can zoom with our middle mouse button, and we can pan with that middle mouse button as well. So you should feel right at home. And then finally, right at the bottom of the screen down here, we've got our view specific options. So our scale, the ability to control the level of detail that we're looking at and things like that. We're just going to draw something really simple for the purpose of today. So we're going to go ahead and draw some walls. And when we start drawing our walls, it's going to ask us, how are we drawing? What are we trying to do? And actually, this gives me an opportunity to just step backwards a little bit, because before we start drawing our walls, what we might want to do is go ahead and look at our elevations. So if I look at my north elevation, you can see that in this model, we actually have two levels, level 0 and level 1. I'm just going to change these slightly. So level 1 is just a little bit closer to level 0. And then I'm going to add another one on top. So let's add another level from my datum under architecture and create level 2. Let's make level 2 about the same distance from level 1. Now you watch what happens if I rename these. What we have is a parametric link between this datum element and the levels that we're drawing on. So this view is this level. This level is this view, and so on and so forth. Everything inside of Revit is parametrically linked. That means that when I start drawing my walls on my ground floor, if I just choose to place one wall, just for the purpose of this, left to right, like so, and go and have a look at my north elevation, you can see here the base of that wall is sat on the ground floor. If this level moves, the wall moves with it. It doesn't resize. Why doesn't it resize? Well, because that wall has been drawn with an unconnected height of 8 meters. I can parametrically connect that wall up to the first floor, and that wall then becomes linked to the first floor in the building. So everything that you do from the offset has more intelligence. It's parametric. It's working for you. And with that in mind, I can start drawing. I'm going to draw an unconnected height of 8 meters, and I'm going to draw a really, really simple design. Let's go approximately 6 meters across. Let's come, I don't know, about 10 meters down, and then just join the dots. So there's my basic building shape that I want to create for the purpose of this demonstration. I've roughly made it centered. I've not coordinated this with real world coordinates. We have plenty of other videos on our YouTube channel. Go ahead and check them out, which will allow you to see how to use some of those digital construction methodologies. But what I have here is these walls. Now, in the background, if I select one of these walls, you'll notice that they have dimensions associated to them. The dimensions are just turned off. And actually, if we zoom in from an AutoCAD perspective, I've done exactly the same as drawing a polyline. Click, 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 click. I've clicked 5 points, start all the way through to the end. And then on each one of those clicks, what Revit's done is it's drawn a parametric wall, which is a fully detailed wall with all of the hatching. Now, this wall is drawn based on a scale, visibility scale of 1 to 100. So I draw it 1 to 1, just like you would on model space inside of AutoCAD. But what we do in our views is we tell Revit, how are we going to be scaling this? What size paper is it going to go on, and what scale are we going to need to put this down to in order to print it on a piece of A3 or on a piece of A0? So what Revit does is it has a number of settings under Manage. We've got all of these settings over here which control our line styles and our line weights. That means that as we come and change the scale, so if I was going to print this at 1 to 500, you'll notice that the lines and all of the annotations around the model get much, much bigger so that they can be read on paper. We define a text height, for example, and it always makes sure that that text height is the same on printed paper or on a physical piece of paper like a PDF. Physical, virtual piece of paper, digital piece of paper like a PDF. If I lower this to something like 1 to 50, everything becomes much smaller because it's assuming that it's going to be on a bigger piece of paper, and therefore it doesn't need to be physically as big on the screen. I want to default this at 1 to 100 inside of Revit, but being used to AutoCAD, I want this to look crisp. I don't want to see the line weights when I'm drawing. I want to see all the finite detail. So I can turn on thin lines, either with the keyboard shortcut, TL. You'll notice that on the, what's the word for them? Mine's gone completely blank. Not view cube, that's the thing that's over here on the left hand side. Tooltip, there we go. So on the tooltip that pops up, if you see any little letters in brackets, that means that there's a keyboard shortcut, which for you AutoCAD users is key, because you're on a keyboard all the time. So if I just type TL, it's going to turn thin lines on. I can also cycle it on and off with the button. But what that does, you'll see, is it makes this look nicer. It looks crisp. It's hiding the line weights. It doesn't print like that. It doesn't go onto a PDF like that. It will always come out the way that your line weights and your line styles are configured. But you can make the model work and view the way that you want to from an editing perspective. So digressing a little bit, we've drawn some walls. If I select one of those, you can see a dimension appears. The dimension's always there. It's just not visible when you don't have the wall selected. They're called temporary dimensions. If I select this wall, I have a temporary dimension between interior finish to interior finish. It's currently 5, 7, 10. If I click and drag the blue dots on the witness lines, I can change that to be an exterior facing dimension. I can then make that exterior facing dimension 6,300. Deselect and reselect, Revit will remember that. Again, if the interior dimension's more important, just pick and drag those across and change the interior dimension. You make a selection and then you change the value in the dimension relating to that. If you want that dimension to be visible and therefore on your sheet views and be printed, just click this little button. The dimension will turn into a permanent dimension, and from there it will always be visible until such time as you either hide it or delete it. It's not deleted, it's still there. It will always be visible. I'm going to leave them off for now, I don't need them. The next thing I'm going to do is just draw some internal partitions. Or maybe I'll draw a floor first. Let's do a floor. So let's go to the floor tool. On the floor tool, we've, again, much like drawing these walls, have got lines, arcs, circles and squares. And actually, when you're drawing or placing anything, what I failed to point out when drawing the wall, it's very familiar to AutoCAD, the offset tool, the trim tool. They work in exactly the same way, give or take, as they do inside of AutoCAD. So from here, I'm going to choose not to draw lines, arcs and circles, but to select existing geometry. I'm going to hover over one of these walls and press the Tab key once. I could select all of them individually, I'm just being lazy. Press the Tab key once to chain select and click my mouse. I can choose whether to join the wall to the underside of the plasterboard or extend under the core of the wall, which is what I'm going to do for the purpose of this, and then press the tick. Revit completes that floor, and if I just jump into a default 3D view here by using the house at the top, or by going to my 3D views in my project browser, you can see that by those very few clicks, 1, 2, 3, 4, 5, and then a couple of clicks to the floor, we've started to get some 3D geometry. To navigate around this 3D view, it's still the same on the middle mouse button, and then hold down Shift with that middle mouse button to orbit around. Now, how is Revit coming up and creating these walls and these floors which are structured or layered? How does it know how to do that? Well, quite simply, it has a structuring system where you define and control the way in which those components are built. Simply put, let's place on some partition walls. So from the Architecture tab, I can go and select Wall. From the Type selector, just here, we can see that in this template, we've got all of these walls. I'm going to go down and select Wall Partition, 12 partition by 75 stud by 12 plaster. I'm going to go and draw some of those on my model. So let's just say, just by eye, I want one about there to there. I want another one about there, like so. And then maybe I also want to have, I don't know, one about there. So what Revit does, if I select one of these and go to Edit Type, we're looking at type properties. So inside of Revit, you have an instance, which is every instance of that component. And then you have a type, which is all of them. That type has what's called a structure. And that structure is basically made up with layers. So we have a finished face, a structure, and another finished face with this example. You can see that each one has a material and a thickness. So if I grab the interior finish and just say that stupidly this is 100 millimeters worth of plaster and press apply and OK, you can see that all of those walls will update on my model. So I have a structural way of controlling and customizing and tweaking what we have inside of the model there, which works really, really nicely. That works the same with the external walls, okay? So you have a way in which you can control the build-up. It's the same for roofs, it's the same for ceilings, it's the same for floors. We control them with this layered setup, and actually it works really, really well. Because of these materials, Revit knows how to wrap things like the plasterboard here. So it can wrap the plaster around, it knows to join the cavities. If we had a block wall, it would join the block work. Revit does a really good job of doing those joins for you, which, should you want to, you can disconnect the joins. So we can disconnect them so it was just a single piece of plasterboard rather than wrapping, but you know, again, it's down to you. So we've got some floor, some external walls here, and some internal partitions. Now what we're going to do is place a door. Okay, now I could place a door from my components that I've got downloaded on my machine. I don't know what's downloaded on this streaming machine, to be honest. It's been a while since I've used Revit on this system. So I'm going to use one of the slightly newer functions in Revit and say, insert an Autodesk family from the internet. Think of these like a block, but a block in Revit is called a family, and each family has its own category. So we've got doors, windows, furniture, steel, annotation tags, you name it. You can see some of the categories here on the left. So let's choose a door. And let's say for the purpose of this, I want a nice external door for my building. And I'm going to come down and select this one I quite like. So I'm going to select this one. I'm going to load it in. That downloads the file and makes it available inside of my, my file here. So here is my door. And again, that door might have multiple different type sizes that it comes in. I'm going to select the 910 standard door, and I'm going to choose to place that on the inside of my building, like so. Now, I've eyeballed that fairly accurately to get it into the middle of the wall, but should you struggle to do that, I can grab the dimension tool here and then use my tab key to cycle through what I'm selecting. So I could go interior finish to the center of the door to the interior finish. I could then place this on the outside and make it equal to force that door to always stay in the middle of those walls. Should this then update, the door will always remain central, which is really, really beneficial. Again, it's called parametric modeling. You can do this kind of stuff inside of AutoCAD, but it's easier in Revit. It's more natural because Revit's been designed from the ground up to do this exact functionality. So we've placed this door. What I now want to do is go ahead and place some other functional doors inside of this building. So let's go ahead and say we want to have a door which is an internal door. Let's load another family down from the internet. So let's insert Autodesk family. Let's go and grab doors again, but this time internal doors. And let's go ahead and grab one of these. I quite like these ones. Let's load these doors in. Choose to place the door. And I'm going to go and grab the same standard 910 door. And I'm going to go and place it over here. So let's come into this room. We're going to have a little cloakroom here perhaps. So let's have a door there. I'm going to place an opening here, so I don't want to have a door over on that side. But actually looking at this, I was hoping to have a staircase up here, but there's clearly not going to be enough room there. So I'm going to drag this wall up, press TR on my keyboard to extend. No, I don't want to do that at all. That's a fib. I'm going to place modify. There we go. Not trim to corner. I want a standard trim. I want to trim using this, keep this, just to get rid of that wall there. And then I'm going to right click and create similar to just place another one there. That'll do. So we've placed some doors. I want to have a look at this wall here so I can have maybe a nice opening so that we've got a bit of a flowing space between here and here. So let's place down a section. The great thing about Revit is because it's live, we can choose to create views, create sections, create elevations whenever we want one. So I want to look at this wall. So I'm going to say create a section view, click once, drag my mouse, click again. I then get a depth of my view and a width of my view. So I want to include this wall and this wall and this wall. I can then double click the arrowhead here, or indeed tile the windows to see that section alongside my other view. In this new section view here, I can say, well, I'm not fussed about what's going on the first floor, so I can get rid of that. And I want to see this in a little bit more detail. I can then select a wall and I can start making modifications to that wall. In this case, I want to select the wall here and I want to choose to edit this wall's profile. So I'm going to choose edit profile. I'm going to use this section to edit that wall. And I'm just going to go ahead and do a real quick mock-up of an archway or something like that. I'm not overly fussed about the sizes. Again, for the purpose of this is very rough and ready. But we are going to use trim to corner, TR on our keyboard. Again, remember the keyboard shortcut there in brackets. And we're going to pick up the corners of this component and then just trace in this other one over here. That's currently quite square. We could put a fillet arc on there if I wanted to. So if I wanted to have some nice round corners, I can place one there and there. I can maybe make those 400 mil or so on a radius, nice big curves, and then press the tick. We've got something that looks like that. Quite happy with that. Let's close down that section, go into our ground floor plan, and we can see that opening is now complete. I'm going to go to architecture and choose to place some windows. I'm just using some pretty bog standard windows in here, but this is going to be a little cloakroom, so we want to have a small window somewhere around there. Maybe we're going to place some slightly bigger windows in the hallway, so maybe we want one as we're coming up the stairs here. Maybe we want a nice large window over here. Maybe this is our dining area or living area or office space. I don't know, I'm kind of making it up as I go along. And then maybe have another couple of windows on the side there, and one maybe over here. In the corner, maybe we want to have a nice glazing corner of the building. So let's go to our wall tool. Let's go and use one of our curtain wall components. Let's make sure that we set that to automatically embed. And again, it's just like drawing a line in AutoCAD. We're just got to get a bit more, we have a bit more intelligence as we're placing those inside our building. So we can come in and it will draw those components for us. Again, we can trim and extend those as we see fit. If I go and have a look at this in 3D, it's going to have done those full height because I didn't change it as I was drawing it. So I'm going to select them and I'm going to say that actually they're only about 1800 high, like so. Perfect. From there, I'm going to place some ceilings. So I'm going to go into my reflected ceiling plans, which are looking up rather than down, so that I can see my ceilings once I've placed them. On the ground floor, I'm going to place automatic ceilings and just click once in each enclosed space. Revit will create ceilings for you, like so. So again, no more difficult than inside of AutoCAD, just a slightly different workflow. I want to draw in some stairs. So common misconception that in these 3D tools, stairs are very difficult to use. Actually, it's quite the opposite. They're really quite straightforward, so long as you appreciate how they work. So if we go to the stair tool in Revit and have a look on the left-hand side, you can see that we've got some dimensions, a number of risers, a calculated actual risers and actual riser height, and then a tread depth. These are calculated based on your type settings and your calculation rules. So you customize these to be controlled in the way that you want to based on these minimums and maximums. As you come in now and start chopping and changing this, 13 risers, Revit's going to tell us, hang on, you said that you wanted to have a maximum riser height and you've gone way over it. So you can tell Revit to adhere to building regulations and get it to tell you when you've gone over those limits. From there, I'm going to choose to draw the exterior right-hand side of the staircase, and I'm just going to trace along this bit of plasterboard here. So I'm just going to click once and start drawing. You can see that that Revit will automatically preview those risers going in, and I need that many risers to complete the staircase. If I stop and leave a gap, it will automatically create a landing. I'm going to go all the way up and click, and we now have our staircase. Just going to click the tick, and I'm also going to use AL, align, on my keyboard to align to the staircase this partition. Go and have a look in our 3D view. We've now got a staircase, if I can find it around here. Staircase is now in. We need to cut our floor that it's coming through and get rid of this, this excess piece of wall here. So we can go in and do that should we want to. Let's go to my ground floor. I'm just going to shift this upwards a little bit just to get it away from the stairs. Perfect. And let's come into the first floor of our building using our views on the left-hand side. Then let's go ahead and place another floor. This time we're going to choose a concrete course floor. And again, I'm going to go and select on every single component wall in my building. but flip the wall so it's sat underneath the plasterboard. If I press my tick, I'm going to say I want to attach the walls to the underside of the floor, for these partitions for example, and I want to cut into the volume of the walls where the floor is overlapping. So in other words, if I go back to this section view from earlier, where this floor goes underneath the plasterboard, like I told it to, it's going to cut that wall, so that plasterboard area has been cut out. Okay, so Revit's doing that kind of functionality for you, which is really, really cool. If I go and have a look at this in 3D, looking good. I just need to cut through where those staircases go. There's a multitude of ways that you can do this, to be honest, but I'm just going to be lazy and use a shaft. So I'm going to go and place a shaft. I'm going to draw a rectangle and very approximately trace my staircase with that rectangle before pressing the tick and going into our 3D view. Our 3D view then allows us to control which slabs, a roof, a floor or a ceiling, are going to be cut by this shaft. So I'm just going to drag the bottom up and the top down a little bit, and we now have cut through for our staircase. We'd typically draw some bulkheads in here using the wall tool or something like that. You'd just create a wall that's just got the relevant components in the structure, and you'd draw those bulkheads in. But for the purpose of today, I'm not going to bother. From here, I'm going to go to my ground floor and I'm going to be really lazy. I'm going to say that I want to copy this wall and all of these windows from around the outside of the building. I'm going to copy them to my clipboard and paste them aligned to the first floor. Revit will basically copy and paste those components, but to the floor above. I can get rid of anything that I don't want as an individual component and edit anything on its own. Okay, so these are now individual components that only exist on that first floor. Therefore, you can do with them whatever it is that you see fit. I'm not fussed about how they are today. It's just a case of showing you that we've got that functionality there. On that first floor, maybe let's go ahead and add 2 quick ceilings, jump up to our roof level and place on a roof. Not a column, a roof. Let's pick existing walls, have a bit of an overhang, certainly not 3 meters. And then we want to define slopes on this side and this side, but don't define slope here and here. Hit the tick. Again, this is all layer based like you saw earlier in the walls, and we have our gable roof. Nice and easy, not too difficult. Now the benefit of working in Revit, hopefully what I'm showing you is not any more difficult drawing in Revit as it is drawing in AutoCAD. When we're drawing a line in AutoCAD, it's click, click. In Revit, we draw a wall, click, click. The process is very much the same. The difference is with the intelligence that's going on in the background, okay? For example, when I've been placing these walls and placing the curtaining and stuff like that, Revit is automatically trimming, extending, and wrapping the material, adding cavity closures and other bits and pieces that you would just have to do manually inside of AutoCAD. So this particular component here, this curtain wall that I've added in, it's cut the wall and it's detailed that for me. If I take this curtain wall out, the wall is still there, so Revit just places it back. And naturally, because that's been done, it's not only updated here in my ground floor plan, but it's also updated in my 3D view and any section views and any elevation views that I have inside of the system. Revit is going to go through and it's going to update everything appropriately for you. It works extremely well and it's very, very powerful when you compare it to the manual process inside of working in AutoCAD. That much is even more true when it comes to working with annotations. So for example, these rooms here, I'm going to annotate them to say that actually they are rooms. And I can just go into an enclosed space and Revit picks them up as a room. So I'm going to place a room in the hallway here, in the cloakroom here, and in this big open space. It's currently one space, as you can see. But then I'm going to tell Revit that we have a room separator between this space, which is partitioned, and this space, because it might be that they have create similar. It might be that they have a open plan, not the tag, an open plan living space and then a kitchen diner or vice versa, but no physical wall. So I can come in and tell Revit to create these any way I see fit. Revit is tagging the rooms automatically and numbering them. And it follows a naming scheme or a numbering scheme. So if the first one was A, it would follow B, C, D. If it was 101, it would be 102, 103, 104. It's quite straightforward at how it works, and actually it's really powerful, saves you a lot of time. It's also now automatically pulling the square footage and the meter squared. I don't really care about the square footage in my example, so I'm going to select any one of these types. I'm going to go to edit the type, so I'm editing all of them, and I'm going to turn off the imperial area to only show the square footage. Again, we can tweak these and customize these how I see fit. I'm quite happy with that. I'm going to place on some dimensions so that they are going to be visible on my floor plan later on. So let's just use my tab key to select the outer extremities of the building. I'm just going to go with 2 really lazy dimensions for the purpose of this. And let's also turn on a color scheme. So I want a color scheme based on the names of my room, but likewise these could be based on HVAC zones, these could be based on lux levels in a room. Let's do them by room number, hit OK. It colors the room, and then we have the ability to place down a color fill legend to show that color based on the name of the room. If you'd rather have it by name, we can change that by room name and hit OK. Currently there's only one room name for all of them, but as I come in and start renaming them, so we've got hall, let's just say this one is a WC, this one is going to be a living space, and this one is going to be a kitchen diner. This will start to update automatically, and we can customize the colors and how you see fit. Now, everything you see in Revit is what you get. So when you have a view, what you see is what will print. But very differently in Revit, we have one model, but we can have as many views as we need. So on this floor plan, if you wanted one that you just use for designing, maybe one showing the floor plan and FF&E, maybe one with room layouts or zone layouts, we can duplicate the view 3 times to have 3 different views of the same thing. But all of them are linked, so they all update accordingly and automatically. For instance, in here now we've got all of this detail, but if I want another view that doesn't show that, I just copy and duplicate that either with the detailing or without the detailing and have a copy of that view. I can also have a dependent that updates with the same detailing, but just duplicate it. And in the duplicated view, I'm going to turn off the color scheme because I don't want it for this particular view. And there I have 2 views that are the same. Oops. 2 views that are the same, but showing 2 very different things. Again, think of what you're going to be placing on your sheets. In AutoCAD, you might have layer states or something like that. You might have several copies of the same floor plan. In Revit, we just duplicate the views to have the same thing, but showing different levels of information or showing more or less complexities. Once we've got something that we're happy with, we might want to start placing that onto a sheet. And again, this is where this becomes remarkably easy in comparison to AutoCAD. So take a look at these elevation markers here. These elevation markers are currently blank. Watch what happens if I go onto a sheet. First and foremost, if I grab my ground floor onto a sheet and place it down, see how this highlights blue? Revit knows that I'm now using that on a sheet. It won't let me place it on a sheet again. It knows it's being used or consumed already. If I place this elevation marker, maybe just the north one for the purpose of this, and place that on the same sheet as well, watch what happens on the view. Sheet A100 View 2, because I've placed that elevation on sheet A100 and it's View 2. That all updates accordingly and automatically for you. You don't need to go and manually remember how to do that or remember to do it before you change a revision or upload a new version. It's remarkably powerful and so easy. It takes away that potential for human error. What about making a design change? Well, it's as simple as it will do it for you. If I go back to the ground floor, zoom in here, and let's make this profile, no, not that profile, let's make a change. So let's make this much bigger. So let's grab this wall and drag it out. So we'll make quite a drastic change. We'll remove the door, we'll move this window over there, that would be a silly thing to do. We'll move these two windows like so. Those changes are propagated in the model. You're not updating one view. The model is updating. Therefore, everything updates. You don't have to tell it to. You don't have to manually update a section view or a detail view or a legend. Everything will do what you've told it to do based on the model updating. So very, very powerful stuff. And then really everything else just starts getting more accelerated when you come to using Revit. Extracting data from this file is remarkably easy, whether that's extracting it onto a schedule to place onto your drawing, or indeed extracting it into something like Excel. So if I go to View and I come across to Schedules and I say Create a Schedule, I might want to come in here and just do something like a simple window schedule, as I've got a few different types of windows around the model. I select the Revit category that I want to extract. Note that I can do a multi-category extraction should I want to. And then I simply choose the type of properties that I want to send across into that particular table. So I want the name of the family, the name of the type, certainly the width of that window is going to be important, the height of that window is going to be important, maybe the U values if you had them in there, maybe the fire rating if you had that in there, and let's have a cost, and finally let's have a count. I want to take those and sort them so that they're sorted by their family name, then by their type name, then by the width of that component, maybe the height of them, and I don't want to itemize every instance. If I hit OK, Revit will give me this, this schedule. So I can see the extract of data. Apart from it's not an extract of data, it is the data. It's just a different way of viewing it. If I go and look at my floor plan and just tile the windows with WT again on my keyboard, watch what happens when I start selecting components in the schedule. They highlight in the model. Watch what happens if I grab this component and change it to a different type. You see how the model and the schedule, they are one. It's not an extraction. It's the same data. It's just updating. It's really, really powerful. In here, I can also update information. So I can say that this window here is maybe £300. I can say that this window is much bigger, so maybe that one is 350. This one is about the same, so let's say again it's 350. And then maybe this one here is 800. I don't know, making it up as you go along. £800. We can come in here and update information. And if we go and have a look at any one of those now and look at its properties, you can see that inside the properties, if we find the cost, they have all been updated. Okay, so we've got live data linking, and at any time we can extract that into Excel, or we can come across and place that directly onto a sheet. It's just another view of that component and of that information inside, no, it's not a legend, a schedule, inside of our model. So it's very easy to start manipulating. For me, that's the huge difference between working in something like AutoCAD and moving to an AEC collection and using something like Revit. You have intelligent data. It's doing a lot for you in the background. You're doing it once, you're doing it right, and you're not having to rely on, oh, I've changed the floor plan. I need to go and update the schedule. I need to update the detail view. I need to update the data extraction and re-push it out. I need to play around with my sheets. Oh, I need to go and update my, my view tags and everything else. Revit is intelligent and it will do all of that work for you. So it's a very, very powerful tool to both design conceptually and design very detailed, so technical detail. It's faster to draw, it's faster to get those outputs. And spend the right amount of time setting up your template and getting all of your components correct. You will not lose any amount of detail on things like your sectional detail, your joinery detail, or anything like that. You can achieve the same level of clarity and the same level of professionalism using Revit that you can by using AutoCAD. And certainly the productivity, once you're over the learning curve, will be really, really boosted. And really, that's kind of what I was going to cover for today. I'm conscious that I've been going for nearly 50 minutes. Time flies when you're having fun. But there is so much more to the AEC collection than just Revit. Revit's obviously the flagship product in there. But clearly, once you've got this data, managing that data is important. And inside of your AEC collections, you also have a product called Autodesk Docs. Autodesk Docs is a flagship common data environment that supports digital construction, ISO 19650 workflows, and it has the ability to manage both your files, data, and project data really, really nicely. You can view files, you can compare files, you can run transmittals, workflows, and more inside of that system. And if you want to see or know more, check out our YouTube channel. There are plenty of videos, demonstrations, and examples of how Autodesk Docs, Revit, Twinmotion, Navisworks, and more inside of the AEC collection can really start boosting your construction workflows and hopefully your productivity. And without further ado, really, I think that's kind of it for today. So all that leaves me to say is, once again, thank you very much for your time. It's always a pleasure to have you with us on a Thursday. We're back next week and we're looking at PLM, so it's a manufacturing topic next week where we look at product lifecycle management processes. So I look forward to going through that with you. Feel free to leave us a comment, give us some feedback, let us know what else you want to see on these sessions, and we look forward to seeing you next week. Take care, enjoy the rest of the week, and until next time, see you then. Bye-bye.